the last thing that we're going to be looking at here is what would happen if we looked at a problem like this. At its core, you may be looking at this thinking, this isn't that bad, but let's think about what's going on here. If I take the derivative of cosine, we get negative sine. The derivative of that would be negative cosine. The derivative of that would be positive sine. The derivative of that would be positive cosine, and we've gone in a loop. If I take the derivative of e to the x, it's e to the x. And if I keep doing that, it's going to stay e to the x. If I flip-flop them, they're going to give me the same thing. So one of the things that you're going to notice here is that this loops. There's going to be a point in time when we need to think about what we have versus what is still in our problem. So we're going to use integration by parts here because we can't use u substitution. Like I said, whenever we see e to the x, we want to make that dv because we can take the integral really easily, and it could make a difference. If we take the derivative of something else, it's going to end up being a little bit easier for us. So I want u to equal cosine of x. I want dv to equal e to the x dx. The derivative of cosine is negative sine of x. The integral of e to the x is my favorite, e to the x. So we are going to use our integration by parts formula. So we have u times v. So we have e to the x times cosine of x, or cosine of x times e to the x, minus the integral of v du. So the integral of e to the x times negative sine of x dx. I'm going to simplify it just a little bit to make it a little bit easier. E to the x cosine of x. We're going to put that multiple of negative 1 out front. So we have minus a negative 1, which turns into a positive. And so we have e to the x sine of x dx. So like I said, we have now made something that looks equally as hard as what we started with. So we are going to try to do integration by parts again. That might seem counterintuitive at the moment, but we need to do it. So we need to pick u and v again. And we are going to make them almost identical to what we did before. U is going to be our trig function, sine of x. The derivative of that being cosine of x. dv is going to be e to the x dx again. The integral of e to the x is still e to the x. And we do our integration by parts again, but we need to remind ourselves what piece is being integrated here. So this is the piece that we are changing, so that is the only thing that changes. So I still have that e to the x cosine of x in the front here. Plus. So now is where I'm going to do my integration by parts. So I have u times v. So e to the x and sine of x are being multiplied together, minus the integral of v times du. Okay, so we're going to simplify this a little bit. I have e to the x cosine of x plus e to the x sine of x. I don't need that parenthesis anymore. Minus the integral of e to the x cosine of x dx. You may not see anything quite right away, but one of the things that you may notice is that we have the legitimate same integral that we started with. And so I'm going to rewrite it. So I have the integral of e to the x cosine of x dx. And we now say that that is equal to e to the x cosine of x plus e to the x sine of x minus the integral of e to the x cosine of x dx. And this is where we are going to do something that you may never have thought of that we were going to do before. I have two integrals, and inside those integrals are the exact same thing. I want those integrals on one side. So I am going to add the integral of e to the x cosine of x dx to both sides. In doing so, I now have two of those e to the x integrals. So I'm going to do 2 times the integral of e to the x cosine of x dx. And that is equal to everything that's left over. So e to the x cosine of x plus e to the x sine of x. We only want one of those two integrals of e to the x cosine of x dx. So we are going to now divide both sides by 2. So I now have the integral of e to the x cosine of x dx, which is equal to e to the x cosine of x plus e to the x sine of x over 2. And we did take an integral, so I need to add a plus c to this. I could simplify this a little bit if I wanted to. I could factor out an e to the x. So we have e to the x times cosine of x plus sine of x times 1/2 divided by 2 plus c. But this would be our answer. So the good news that I have for you is you will never be asked a question like this on the AP test. In fact, I will not ask you a question like this on any test that I give you. At most, you may see this in college, but that's going to be it. You will never be asked to do a problem like this again unless it is part of something you are working on that is very specific. What that might be, I don't know. But this is more of just seeing that we can use integration by parts. It can go into a loop, and then we can get ourselves out of that loop. So integration by parts is one of those things that we are going to end up using quite a bit for integrals that are now harder than what we were dealing with from before.